tolerancing, GD&T in short. The key objectives of this E-Train module on GD&T is to take you through an introduction to GD&T, the need of GD&T in engineering drawings, the 5 groups of GD&T parameters, the hierarchy of GD&T implementation, then a clear understanding of MMC, LMC and RFS conditions, when each condition would be applicable, then the meaning of bonus tolerance and its advantages, then datum reference frame DRF, how primary, secondary and tertiary datums together constitute a DRF, and how degrees of freedom are constrained by a datum reference frame. Multiple plates are there, right from bottom plate to top plate, through cavity plate, core plate, etc. Even here the parallelism of the individual plates are very critical. The alignment of the guide bush to the core plate and the alignment of the guide pillar to the cavity plate are important to have a uniform closing and opening whenever the mold cycle operates. Similarly, look at the third example, which is nothing but a machine tool spindle assembly for a vertical machining center. Here I have the spindle housing, then I have the spindle running through and through, and I have the angular contact bearings. Here also, when you consider the spindle, the straightness or cylindricity of the spindle is one of the important parameters. Then the run out of the individual features with reference to each other are important, and the remaining groups of parameters. Form group of parameters, they do not require any datum references, they are applicable for individual features available in the part, whereas the last 3 groups coming under orientation, location and run out, they require datums in a compulsory manner. What is the group coming under profile? In the first column, it is mentioned as it is applicable to either individual features or related features. What is the meaning? Profile controls can be applied with datums or without datums. If they are used without datums, they act more like a form control, and if they are used with datums, they act more like a location control. Then the difference between the maximum and minimum reading of my dial indicator is my measure of flatness error. Well, is there any other method? The third method could be to use a surface plate having a hole at the center in order to receive a dial indicator upside down. If the surface plate is having a bore, I can keep the dial indicator upside down and I can have a direct reading on the required surface.
It is within 1 or 2 microns. Okay, this is a very small area where we can check it. So, one is that since the flatness of this inspection table is within 1 micron or 2 microns maybe within this small area, the complete area is within 5 microns. Okay. So, if we check this component, we can use a feeler gauge. So, I am just using a feeler gauge which is 100 microns. Okay. Now, we can see that it is entering. Okay. This is entering here. Can you see this? It is entering. Okay. Now, when I check it with the 0.2, it is not entering. So, if my flatness level is 0.2 is allowed, if the flatness of 0.2 is allowed, then this part can be accepted. So, actually the flatness it's
we wonder what is GD&T, why is it required for me, or what is in it for me, is it required only for the designers, is GD&T really makes the design easier, makes the manufacturing simpler, etc. Yes, the answers are here. GD&T is a system of symbols, rules and definitions enabling the designer to communicate his design intent clearly in the drawing. The origin of GD&T is from ASME and